AP Calculus, section 6.2, page 2. Starting right here, we start to look at some trig functions. And when we have trig functions in an integral, and we're going to use substitution, typically we want to choose the inside of the trig function to be the u. So we will let u equal 3x squared. Then du is 6x dx. Rewriting this integral up here, let's pull that 18, that constant multiple, outside, and we'll have x. And then let's replace out this 3x squared with a u, so cosecant of u, cotangent u, dx. And again, let's rearrange and let the u parts go up front, cosecant u, cotangent u, times that x dx. And right here we can see that x dx is 1/6 of du. So x dx right there, 1/6 du. And let's pull that 1/6 out front. And 18 times 1/6 is 3. And then the antiderivative of cosecant u, cotangent u is negative cosecant u plus a c. Distributing that 3 back through and replacing out the u, we have negative 3 times the cosecant of 3x squared plus 3c, which is just a different c. And there we go. There's our final answer. The last 3 integrals on this page all have bounds. When we look at number 6, one of the first things that we might want to do here is to rewrite this so that we see this square on tangent as an outside exponent. So let's rewrite this as the integral from pi over 6 to pi over 3 of tangent x quantity squared times a secant x quantity squared dx. Now, we have an inside of a trig function which is just an x, and at this point in your calculus life you won't ever choose that u is equal to x. At a later point you will, using a different technique for integration, but at this point we don't ever choose u to be x. We do have quantities raised here to a power. One of them will be our u. And if you think about this, if we choose u to be tangent x, then du is, derivative of tangent is secant squared x dx, which is that piece right here. So that works out very nicely. If this one hadn't worked, you wouldn't have been able to get rid of all of the pieces in terms of x that you needed to. So when we start substituting through, we are going to have u squared times secant x squared dx. Now notice that I have dropped off the bounds. The bounds are no longer there because these were x bounds up here originally, were bounds on x. Well, down here in this integral we have u's and x's mixed up, so we don't keep those same bounds. Finishing our u substitution, we can replace out this secant x dx with just this du right here, and we'll have the integral of u squared du. Alright, now we are completely in u's, so we are going to change our bounds here to be bounds on u. And the way we're going to change those bounds is by using this u substitution right here. The u is tangent x. This is the upper bound on x was pi over 3, so to find that bound right here, we will do the tangent of pi over 3 And if you think back to the unit circle, I'm just going to put that right up here. Pi over 3 is right there. Sine is square root 3 over 2 over cosine half. So that's square root 3. So this upper bound is square root 3. The lower bound down here is the tangent of pi over 6. Pi over 6 down here in the lower part of the first quadrant, that's sine 1/2 over cosine square root 3 over 2, 1 over square root 3, which if we rationalize is square root 3 over 3. Now we have bounds, u bounds, so we can handle this. Do the antiderivative of u squared, so 1/3 u cubed, and we are going to, oh, no plus c this time, no plus c because we have bounds, and we're going to evaluate this from square root 3 over 3 up to square root 3. I'm out of space, so I'm going to come up over here, and we'll have 1/3 times the square root of 3 cubed minus 1/3 times square root 3 over 3 cubed. Square root 3 cubed is 3 square root 3, which simplifies down to be just square root 3. On this second one, that 1/3 square root 3 cubed is 3 square root 3 over a 3 cubed, 27. We end up with square root 3 over 27. We can combine those two because they are like radicals. If you think of that as a square root 3 over 1, now you can get a common denominator. 27 square root 3 over 27 minus square root 3 over 27 is 26 square root 3 all over 27. There is that final answer. Looking on to number 7. We have really two functions here to take a look at. We have this natural log function, and we have x. Well, we know we aren't going to choose u to equal x, so u has to be the natural log of x. Then the derivative du will be the derivative of natural log 1 over x dx. And when we start to substitute this out, the ln x becomes u over x dx. Again, notice no bounds here because we have u's and x's mixed up. Let's rewrite this line right here to rewrite it as u times 1 over x dx. Now you should see that this 1 over x dx is du. So we have the integral of u du. All right, we are completely in u's now, so let's fix our bounds. And we're going to use this u substitution. So for this upper bound, we need the natural log of e cubed. Remember, in your log rules, you could pull this 3 down in front, which is 3 times the natural log of e. And the natural log of e is 1, so this upper bound is 3. On the bottom down here, we have the natural log of 1, which is 0. Have the bounds. We're in completely u, so we can do an antiderivative. The antiderivative of a u is 1/2 u squared. No plus c here because we have bounds. We're going to evaluate from 0 to 3, which is 1/2 times 3 squared minus 1/2 times 0 squared, or 9/2. Oops, raise this up so you can see it. There we go, 9/2. Looking at this next one over here, number 8. This one's a bit harder to see because just something you're not used to seeing right now, and you probably won't see the U substitution that I'm choosing right off the bat, and that's okay. I will explain it after we get just a little bit farther into this problem about why I chose what I chose. So first thing right off the bat is let's get this 40 constant multiple outside of this integral. So we'll have 40 times the integral from 0 to 5 of 1 over x squared plus 25. Now again, I'm telling you this u, and you won't see it right away, but that's all right, just hang with me. This is x over 5, which if I rewrite that is 1/5 x, so that du then is just 1/5 dx. When we go to substitute out, there's nowhere really to substitute in the u when we've got it set up like this, u equals x over 5. So let's rethink this. Could I write this as x is equal to 5 times u? And then that means we can make this 1 over, and this x squared plus 25, 5u squared plus a 25. Uh-oh, I made a goof. I'm going to have to fix it in a minute. Dx. We can't have bounds on there. I have u's and x's mixed up. So I'm going to go back and pull those bounds out. I'm so sorry. All right, now dx, we have to trade that out. And dx is going to be 5 du. Now rather than writing that 5 on the inside, I'm going to go ahead right away and pull that 5 out here. And let's square out this 5u, so 25u squared plus 25. And then this dx, well, that was the 5, which we put out here, du. All right, now we're all u's. Now we can find these bounds. Right here, using this substitution, u is x over 5, so u is 5 over 5, which is 1, and down here, u is 0 over 5, or 0. Cleaning this up a bit, we have 40 times 5, which is 200. We have the integral from 0 to 1. Look inside of here. We could factor a 25 out of that denominator. And then that 25 is a constant multiple. We can just pull that out as well. So we have 200 divided by 25 times the integral of 1 over u squared plus 1 du. Do you recognize that? That is an inverse tangent of u. And 200 divided by 25, that's 8. So we have 8 inverse tangent of u evaluated from 0 to 1. Pulling this up here to complete, evaluate, we have 8 inverse tangent of 1 minus 8 inverse tangent of 0. This is asking you where on the unit circle is tangent equal to 1. And tangent is equal to 1 at pi over 4 minus 8. Over here, this one is asking you where on the unit circle is tangent equal to 0. Tangent is equal to 0 at 0. So we just have 8 times pi over 4, which is 2 pi. Isn't that fun? All right, now let's go back. How did I know to choose that x over 5? When you have this kind of situation where we have a constant over, and in this denominator down here, if we have this denominator is x squared plus some a squared, then choose u is the square root of x squared over a squared. And that's exactly what I did here. X squared over a squared, so x squared over 25. The square root of that is x over 5. So this is kind of when you have this situation going on or something similar to that, then that's the u substitution you're going to use. There's a whole page in your homework. I think it's a puzzle page on page 17 in your homework that is all this kind of situation. So if you take a look at that, hopefully you will get the hang of it. Thank you very much, and you can join me on page 3 tomorrow.